How's it going, everyone? Today we're going to learn about a very interesting type in Python which I didn't even know was used until today. This type is the NotImplemented type, and its use case is actually really cool. But before we dive in, I'd just like to thank Zed for sponsoring today's video. I really like their code editor, and have been using it for quite a while now. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. So, what is NotImplemented? Well, NotImplemented is a special built-in singleton that you will primarily see being used with dunder methods. And I do want to quickly mention that NotImplemented should not be confused with the NotImplemented error, which you'd raise in methods in abstract base classes or in unimplemented functions. The key purpose of NotImplemented is to enable rich comparisons and make Python perform a little extra magic when it has to compare or figure out how to use two objects together. In some cases, when you define a class, you're going to want to be able to support operators like the is=to operator or the plus operator. Now, imagine you've implemented these dunder methods, but your object encounters a new operand it has never seen before. In this case, you should return NotImplemented, rather than raising a type error or returning false. Let me show you why. First, let's import the AnyType. Then we're going to create two classes that both handle numbers. The first one will be called number. All it will do is hold a value. Then we will implement the dunderEQ method for it and make sure that it only performs the equality comparison check when the other type is a number type. If the other type is not an instance of number, we will return NotImplemented. At the bottom, we will define a dunder method that allows us to easily see the value of our object when we print it. Then we're going to create a second class and essentially do the exact same thing, except this time we'll make the comparison operator much more flexible by allowing for both numbers and integers in the comparison. And once again, we will return NotImplemented at the bottom. Now we can create two instances that both contain the same value. And when we try to compare them, it will work just fine. Even if the number class did not accept any type other than the number type, it was still compared with the integer type. But how? Well, NotImplemented essentially tells Python to not give up and to search the other class for any compatible comparison logic first, before giving up completely. This gives your object a second chance at being compared with logic that's already present in the program. Let me show you now what would happen if we raised a type error or returned false instead. So let's go back up to the number class, and here we're going to start off by returning false. First of all, returning false is incredibly misleading because in terms of user experience, they might think that the objects are compatible and that the EQDunder method was implemented correctly. But for some reason, every time you try to use the comparison operator, it's going to return false. So they will definitely be scratching their head at that. It works, but it's just not what we want, because at this point we do not know yet that integers and numbers cannot be compared via the number class. Otherwise, you could raise a type error, which is much preferred over returning false, because at least it gives the user a chance to understand that they are trying to compare two incompatible types. As you can see, when we try to run our code again, it will raise a type error correctly. And if we expand this, it will show us where we encountered it. But this is still not what we want, because the other class knows how to handle this operation for both types, and it's silly not to check in the other class before giving up completely. So to make sure that we check the other class as well, all we have to do is return NotImplemented. Now this will check the other class to see whether it can perform the operation with the number class before giving up completely. And as you can see, when we return NotImplemented, it works just fine, because it was able to use the EQDunder method that belonged to the integer class, which accepts both numbers and integers. I should also mention that the order matters here. The implementation for the EQDunder method will depend on which object is on the left side of the comparison. If we were to go back to the previous example where we raised a type error, right now the code would crash, or it would raise a type error, because numbers cannot be compared to integers. But if we were to swap these around and compare an integer to a number, this would work just fine, because integers know how to be compared to numbers. But relying on the order is not really professional. You want it to work the same way, regardless of which object is on the left side. That's why it's important to raise or to return not implemented. And honestly, I never knew this until recently. I was just writing a script on the not implemented error when I noticed a typing suggestion for the not implemented singleton. So I decided to look into it because I thought it would have been related to the not implemented error. But I was wrong. Its functionality is much cooler than anything I could have imagined, and I'll start using it in my custom classes whenever I get the chance. Because every object deserves a second chance when performing an operation. To put it into context, imagine you and your friend have a recipe book, and you've been put in charge of reading the ingredients out loud. But all of a sudden, you encounter an ingredient you've never heard of before. Instead of giving up and ignoring that ingredient completely, you'd ask your friend first if they knew what that ingredient was, and if they did, you'd both be able to continue with following the recipe. That's essentially all that not implemented is. It tells Python to check if the other object might know how to handle an operation before giving up completely. Anyway, I'd love to hear your thoughts regarding this feature in the comment section down below.